strain gauges using 2 SP10 systems and 3 P3500. What you will need to do is you need to adjust the gauge factor, which is listed in the material section number 2, which says SA, or the gauge factor is 216, and you have all the dimensions for the spring: the internal diameter of the spring, the outside diameter, and the diameter of the wire itself. And you can find the specifications or the information about the location of the rosettes or rosette strain gauges in the table 1 of the project handout. And there are 3 of them located in the same place and same direction or alignment, just for to repeat the measurements and for you to compare and see if the readings are correct or not. And then
say cheese.
there are 2 groups of 2 rosettes. They're again located in the same place and aligned in the same direction. You can see the configuration of the rectangular rosette in figure 3 of the project handout, and the schematic or the figure that shows the location of the strain gauges on figure 2. So we divided the strain gauges into 3 groups: Group A, Group B, and Group C. And this is the detailed information about the channels and the gauge numbers that are connected to each channel. You already learned how to use these SP10 systems and P3500 systems. So you should be able to adjust the values and work with them. The other thing that I would like to mention is that, so group system A will cover strain gauge A, B, and C from channel 1 through 9, as you see it's listed here. Then group B will cover or will provide the reading for gauges D, E, and F. And then we have 1 channel left in group A and B, which is the legs, the first and second leg of the strain gauge G, and the third one is directly connected to the P3500 system, and so you can directly measure the strain of the G tree from this third P3500 system. So what you will monitor in this part is the strain values of the strain gauges. Using the frame and this dial indicator, you will measure the displacement, and the system you will measure the load that is being applied to the spring. Any questions so far about this?
Are you going to show us like a sample?
I'm just going to briefly show you how you can operate this system, because this is slightly different and you will have more control over it. And you're not going to use the hydraulic system, although you can use it, but you're going to use this screw to adjust the top fixture to be able to apply the load or to change the displacement. Any other question? Okay, so the spring will be located here when you're coming for the experiment. What you need to do is to adjust this dial indicator for measurement of the displacement. You might need to go to 100 millimeter of displacement, but this dial, which is around 4 inches, but this dial can go over 2 inches. So in case you need to go over the 2 inches, you need to readjust it when you reach the limit of the dial indicator, and I'm going to show it to you how. So the first thing you need to do is to put the load cell in the low range, because you're not going to exceed 12,000 pounds for the load. So you'll adjust it to low, and you need to zero it, but since we can't zero it in low range, you will need to adjust it to a value. I'm going to put it for 20 pounds right now, and what you will need to do is to adjust the height of this, so you will have the maximum range of the indicator at the beginning or for the first section of the experiment. So I'm just going to adjust it here. Make sure that it's vertically aligned and it's not tilted. And then to make sure that it's not moving, you turn on this magnet, which is serving as the base for this indicator, and then you need to zero this. So now I'm set for the experiment, although I need to adjust the strain values here as well. what should we do to be able to read the strain values? Does anyone remember? What did we
Offset
do?
value. Isn't it? Offset, you have to find the offset
We need to
value.
balance them first to 0. If you can, then you can adjust it to an offset value, which needs to be subtracted from all the measurements while you're doing calculations. So,
Should the spring be contacting the top support before you do anything, or does that, I guess it
yes,
doesn't matter, you can...
it should be very close because I don't. Then that will be the displacement for the spring. You want to record the spring, the displacement in the spring. So I'm gonna actually bring it down until I feel until it's getting very close or almost touching the spring. So as I said, for this, for your experiment, you're not going to use the hydraulic because this one you can have a better control over the movement of the top fixture. In case you exceeded the increment that you want to test, you can go back and you can adjust it to the value that you want. So I'm going to readjust this because I want to be able to use the Now I'm ready to load the specimen, so I can, for example, if I decide to do the increments of 550 times 0.05 inches for my measurement, so I'll put it there, and then you can do the readings for the load and the strain values. And you can go up to, as I said, 2 inches while you're doing the measurement. And in case you want to go further and you reach the limit for this, you can simply record this data and then move this into a lower position and readjust it, 0 it, so you'll have another 2 inches to go. And simply you can load or unload the spring again and record your measurements.
So you have to keep doing that until, for each increment?
It depends on what you want to do. It's all described in the handout and what is requested. So you need to plan for your experiment based on the things that have been questioned or requested in the lab or in the project handout.
Sweet.
Any questions about this one? Alright, so if there's no...
I'd like a reminder on how to use this.
Yeah. This thing is crazy.
This thing? Okay, so if you want, you can come closer to be able to see.
There's too many wires. I know,
Yeah,
right?
you're not gonna touch them.
Jermaine,
So
can I put my head on your head?
No.
you can adjust the gauge factor by using these options. So if you press it, it will show you what is the value for which is set for the gauge factor, and you can adjust it using this knob. Make sure it's unlocked, and then by rotating that, by turning this knob, you can adjust the value for the...
Like to zero it.
No, this one is the gauge factor. This is the value which is reported by the manufacturer of the strain gauge, so that it can convert the reading from the electric circuit and can convert it to the correct strain values. If it's not adjusted correctly, then it will give you the wrong reading, so you can't use the data. I mean, the data won't be correct. So you need to adjust it, and I already mentioned what is the gauge factor, and it's 216, and it's mentioned 2.16. And it's already mentioned in the project handout. Once you set it, you go to the run mode for the indicators, and then what you need to do at first is to make sure that the each channel is balanced to 0, or if not, it is adjusted or balanced to a specific offset value. I'm not going to do it because now the spring is
Right.
So there's 20 strain gauges?
There are 21 strain readings for each leg of the gauges.
Yeah.
We have 7 gauges, each has 3 legs,
Okay.
and each will measure the strain in 3
Orientations,
directions
yeah.
or orientations.
Splendid.
And then, so for example, for this one, if you want to adjust the number channel 1, which is setting B, which will be D1, so you adjust it to channel 1, using this you can change the channels, and then unlock this knob, and then you need to adjust it to a value which you want. For example,
Okay.
if you can 0 it, 0, if not, then you can adjust it to a value, and then lock it to make sure that no one turns the knob by mistake while you're doing the experiment too.
Is there a label between A and B, or like we're just supposed to
No,
remember?
this top row or this first system is A, so it's the first 3 are for gauge A,
Okay.
second 3 are for gauge B, third 3 are for gauge C. They're listed here, and then number 10 is G1 for the gauge G.
Mm-hmm.
This is system B, right? So first 3 are gauge D, the second 3 are gauge E, and third 3 knobs are for gauge F. The last one is the G2 for gauge G.
Mm-hmm.
And then this one, which will directly reads the strain, is for G3 of the gauge G.
Say I had a question like that when we were doing the thing, and I was like, hey, which one's A and which one's B? Would you tell me the answer, or I would just like, this one
You
looks
have the
like
map, you have the equipment, all everything.
A, B, C.
I got it.
Okay.
So, prior to taking any measurements, we should go
No.
through each channel
No mercy.
and make sure they're all zero
Yeah, they are balanced.
before we
10
start.
dollars.
All of them are zero.
Say.
Zero.
It depends. If you want to have reading from all the strain gauges and from all the channels, yeah, you should do that.
Okay.
But since we have A, B, and C are showing or almost indicating the same values, you probably don't need all of them. It all depends on you. We can check it and make sure that, for example, one of these strain gauges might be broken because of something, because of the discontinuity in the wires, or because of the soldering process or whatever. So you have 3 of them to be able to do the reading. One might not show the correct values, but the other 2 should show it correctly.
It's like that.
It's going on YouTube.
Yeah, you're gonna be famous. Like,
So many views.
Yeah.
So,
that'd
yeah.
be creepy. That'd be so creepy.
So those strain gauges are actually like
That'd be so
soldered
creepy.
onto the
Get Joe.
Yeah.
Get Joe. He has crazy stuff. Woo! Sorry.
It's gonna go on. Engineers
This is
Gone
going
Wild.
to be an interesting project.
Engineers Gone Wild.
So there was a rumor going around that somebody, that the machine was